My name is Mauro Casella. We are in Orbassano, near Torino, at the headquarters of CRF, the focal point for research activities of SCA. The main mission of CRF is to develop technologies and methodologies related to powertrains, vehicle systems, processes and materials. And CRF was one of the main promoters for the OPTEMUS project, dedicated to the development of new technologies for the enhancement of electric vehicle ranges.
In the EU-funded project OPTEMUS, we have developed a bunch of innovative technologies in order to decrease the energy consumption for passenger comfort and component conditioning, and thus to increase the driving range, especially at extreme weather conditions.
The Optimus demonstrator vehicle is one of the main achievements of the OPTEMUS project, and it allows us to test all the technologies developed in the project. With the final testing activity in climatic chamber, we were able to achieve very interesting results. As a major achievement, we can say that we reach minus 60% of energy consumption in winter condition and minus 18% in summer condition.
Okay, so all of this started, perhaps at least 5-6 years ago with a call on energy efficiency for electric vehicles. And it's nice to see that from the inception of the proposal to the project, now we have, a set of solutions that are quite impressive.
I'm Giovanni Spagnuolo from the University of Salerno in Italy. We focused our activity on the PV harvester and especially on the novel controller, which is able to maximize the power produced by the PV roof of the car. The idea was based on the fact that the PV roof was fractionated in several parts and controlled by only one microcontroller, so that distributed power electronics and centralized control for maximizing the power produced by the PV roof.
Energy harvesting technologies help in order to extend the range of electric vehicles because they contribute to the charging of the battery of the vehicles during the use of the vehicle itself. The first technology is a regenerative anhydraulic shock absorber able to convert the kinetic energy due to the movement of the suspension into electric energy. This electric energy can be used in order to recharge the battery of the vehicle.
Eco-routing is a connected driver assistance system that computes the best energy efficient route by using several information such as real-time traffic, road slope and weather conditions, and of course using a physical model of the car. So we at IFPEN, we developed a web service. Here the user can select its origin, its destination, and then the system computes the best eco route and compares it with the shortest route and with the fastest route in terms of energy consumption, but also in terms of time and of course distance covered.
A microclimate is created in the interior of the car in order to reduce the energy consumption of the climatization, and this is achieved by means of the smart seat and the radiation panels.
So, during winter, when ambient temperature is cold, the smart seat and the smart panels enables to decrease the ambient temperature, the ambient air temperature, and therefore increase the efficiency up to 34%. And also in summer time, it's in the other way around. So it enables to increase the air temperature and therefore also decreasing the energy consumption of the car.
In OPTEMUS project, we developed the simulation methodology to virtually prototype the thermal comfort and safety for the passenger in electric vehicle in holistic approach which take into account all the conditions around the vehicle like weather and traffic and battery and energy consumption. So in this detailed simulation we have the smart seat, we have a specific dummy for thermal comfort, sensation, And also, based on this reference model, we developed a parametric reduced model to deal with design exploration for the cabin and also for real-time control for optimized energy for optimal comfort and maximum range.
So, the Optimus battery consists of a novel thermal insulating composite housing. And integrated into this housing is a phase change material to store heat. Using preconditioning strategies, we can store 1.9 kilowatt hours of thermal energy to heat and cool the cabin. And during fast charging, we can buffer and absorb 1 kilowatt hours of heat just using the phase change material.
This compact, high efficient and high performance refrigeration unit using a natural refrigerant is providing hot and cold water for cabin heating, cooling and dehumidification, and for thermal conditioning of the powertrain components, for example the battery. This is for us the first European project we are attending, and I think it was a fruitful and harmonic collaboration.
In the context of EU-funded projects and programs, we need success stories. Optimus is one of the good examples for this, and we look forward to the next steps by bringing these technologies to the next level, that is industrially pre-competitive solutions that will be taken up by the automotive industry for future generations of electric vehicles. Okay. This is one of the main concerns for electric vehicles, managing the energy budget as well as extending the range. Optimus offers a number of solutions for this, and we look forward to their next successes.
So after 4 years of development with 15 partners from 5 European countries, the Optimus technologies are ready to improve the future of electric mobility.